In this video, we will discuss about electrophilic substitution reaction of aniline. Aniline, we know very well, aniline is stabilized by 5 resonating structure like this. Aniline is stabilized by 5 resonating structure. And in the 5 resonating structure, you know very well, there is electron density on ortho as well as and para position. There is electron density on ortho as well as para position. It means, and so on. There are 5 resonating structure of aniline. In aniline, when we draw the resonating structure of aniline, it is stabilized by 5 resonating structure. In the 5 resonating structure, aniline acquire negative charge on ortho and para position. It means electrophile attack on ortho and para position. Thus, aniline undergo electrophilic substitution reaction at ortho and para position because in the NH2 group in aniline is powerful activating group. It donates its electron pair to benzene ring and make it activate towards electrophilic substitution reaction. Got it? Next, how many electrophilic substitution reaction? There are 3 electrophilic substitution reaction. Number 1, bromination. Bromination of aniline. When aniline treated with bromine, this aniline treated with bromine in high polarity solvent, say for example water molecule, aniline treated with bromine, they form 2,4,6 tribromoaniline. 2,4,6 tribromoaniline. Here we cannot get ortho and para product separately. What is the reason? Reason is that in aniline there is NH2 group is powerful activating group which activate the benzene ring towards electrophilic substitution reaction. If we want to get ortho and para product, say for example ortho bromoaniline and para bromoaniline, first aniline undergo acetylation. First aniline undergo acetylation, then bromination. If we want to get ortho and para product of aniline, say for example ortho bromoaniline and para bromoaniline, aniline first undergo acetylation and then bromination. Say for example this aniline this treated with acetic anhydride. Aniline treated with acetic anhydride. Say for example ethanoic anhydride. In that case, there is the addition of acetic acid CH3COOH and there is the involvement of aceto group in the aniline. There is the involvement of aceto group in the aniline. This group control the activating power of this NH2 group. This group, aceto group. How? This is NH, this CO and this CH3. Oxygen is more electronegative than carbon. This electron pair shifted towards oxygen. This carbon carrying positive charge. Thus, this electron shifted towards this. There are this stabilized by 2 resonating structure. This carry positive charge and this oxygen carry negative charge. Here there is nitrogen carry positive charge. Thus electron density on nitrogen goes on decrease when aniline undergo acetylation. It means when aniline undergo acetylation, the activating power of the NH2 group can be controlled. Now when this after acetylation, when this acetylation product undergo bromination, तो यहाँ से देखिए there is ortho product as well as para product should be formed. There is ortho product and para product should be formed. But when aniline not undergo acetylation, we cannot get ortho and para product separately. Here, after getting the ortho product, we undergo the aniline, this product undergo hydrolysis, and after hydrolysis, we get the ortho product or para product. We get ortho product, hydrolysis, then the elimination of CH3COOH, and then the formation of NH2. It means we got ortho product as well as para product. Got my point? Aniline, when react with bromine in water, we get 2,4,6 tribromo aniline. But when aniline undergo acetylation, then the aceto group is introduced which control the activating power of NH2. Thus, this product when undergo bromination, we get ortho and para product separately. Next is the nitration of aniline. This is the bromination, and if in a bromination, if we want to get ortho and para product, aniline first undergo acetylation, then bromination. Second is the nitration. Nitration of aniline. When aniline, this aniline treated with concentrated nitric acid, aniline treated with concentrated nitric acid in presence of few drop of sulfuric acid, aniline treated with concentrated nitric acid in presence of few drop of sulfuric acid, that is the nitrating mixture, we get ortho product, we get, this is ortho product, para product, we get the ortho product, para product, and in addition to these ortho and para, we got meta product also in very large amount, in nearly about 47%. Aniline, when it undergo nitration, there is the formation of orthonitroaniline, paranitroaniline, but in addition to these, there is also for meta-nitroaniline in the huge amount. What is the reason? Aniline, when resonance stabilized, it carry ortho and para position becomes negative charge. But why this? There the meta product form during the nitration of aniline. Reasoning that when aniline react with strong acid, when aniline react with strong acid, the acid release proton H positive, and after accepting a proton, aniline form anilinium ion. After accepting a proton in the strong acidic condition, aniline react with H positive ion to form anilinium ion, which is meta directing group. Thus, we got meta product in very large amount. I repeat, nitration of aniline, when aniline treated with nitrating mixture, we get ortho, para. In addition to ortho and para, we get meta product also in the large amount. What is the reason is that? Reason is that aniline, when treated with concentrated nitric acid, strong acidic condition, after accepting a proton, they form anilinium ion, which is meta directing group. Thus, we got meta product here also. Next is the sulfonation. Sulfonation of aniline. First is the bromination, second is the nitration, and third is the sulfonation of aniline. Aniline, this aniline treated with concentrated sulfuric acid, aniline treated with concentrated sulfuric acid, this aniline after accepting a proton to form anilinium ion, after accepting a proton to form anilinium ion. And now here there is the formation of sulfonic acid. There is a formation of sulfonic acid. Sulfonylic acid. This sulfonylic acid, this group NH2 group is basic group. This group is acidic group. This group release a proton, and this after accepting a proton to form a dipolar ion. To form a dipolar ion. This is acidic group, release a proton. This is basic group, accept a proton to form dipolar ion, which is known as jitter ion. Which is known as jitter ion. So when aniline undergo sulfonation with the help of concentrated sulfuric acid, when aniline treated with concentrated sulfuric acid, it forms sulfonic acid, which further give jitter ion. Why? The acidic group, the sulfonic group is acidic group, NH2 group is basic group. This release a proton, this accepting a proton to form a dipolar ion, which is known as jitter ion. This is the sulfonation of aniline. Next is the number 4, Friedel-Crafts alkylation. Next is the Friedel-Crafts alkylation or acylation. Friedel-Crafts alkylation or acylation. Aniline, when undergo acylation or alkylation, in Friedel-Crafts alkylation or acylation, we use aluminum trichloride act as catalyst. In the Friedel-Crafts alkylation या acylation, we use aluminum trichloride as a catalyst. Then aniline, this act as Lewis base because they have a tendency to donate electron. AlCl3, aluminum trichloride, act as Lewis acid. This, after donating a lone pair of electron to this, we give a salt, NH2 positive, AlCl3 negative. And here nitrogen of the aniline carry positive charge, thus activating power of aniline can be controlled. This acts as deactivating group. This not activate the benzene ring towards ortho and para position, towards electrophilic substitution reaction. Thus aniline, when undergo alkylation or acylation, it react with aluminum trichloride, which act as a catalyst in the Friedel-Crafts alkylation or acylation. Here aniline react with Lewis acid, aluminum trichloride to form salt, which is deactivating group and not activate the benzene ring towards electrophilic substitution reaction at ortho and para position, towards ortho and para position. And this is all about the electrophilic substitution reaction of aniline. Number 1 is the bromination. Number 1, bromination. Number 2, nitration. Number 3, sulfonation. And aniline do not undergo Friedel-Crafts reaction. Friedel-Crafts reaction. Aniline do not undergo Friedel-Crafts reaction because in the Friedel-Crafts reaction, aluminum trichloride act as a catalyst. Aniline react with this to form salt, which is a deactivating, not activate the benzene ring towards electrophilic substitution reaction. In the bromination, when aniline treated with bromine in high polarity solvent, say for example water, we get 2,4,6 tribromoaniline. But if we want to get ortho and para product, aniline first acylation, then bromination, then we get the ortho and para product. In a nitration, when aniline treated with nitrating mixture, concentrated nitric acid in presence of concentrated sulfuric acid, this is nitrating mixture. This aniline treated with concentrated sulfuric acid in concentrated nitric acid in presence of sulfuric acid, aniline form orthonitroaniline, means ortho product, para product, but in addition to these, they also form meta product. Why? What is the reason? The reason is that these are strong acid. They release H positive ion in the solution. तो aniline after accepting a proton which form anilinium ion which is meta directing group, and aniline do not undergo Friedel-Crafts reaction because in the Friedel-Crafts reaction aluminum trichloride is used